Alright, hey guys, welcome to Drunk Geology Episode 1. Sponsored in part by Sky Vodka. Alright, so at this point, you should probably have figured out how to plot your east limb and west limb data. If you haven't, and here's a quick rundown, at least if you can't figure out which is the east limb and the west limb. You're going to want to start with bedding because that's the easiest to plot. So, go to your field notebook, and let's flip to the other page. Alright, so this is my east limb data. It goes from the Cambrian Ordovician Hatch Hill Formation to the Ordovician Mount Marino Formation. It'll encompass from Hatch Hill to Pulteney to Indian River to Mount Marino. And should go in that order. If you go to your map, then it should be everything. Hopefully you marked it on the field trip. Everything east of this point, which is where the fold was, the fold axis that we saw. Everything east of here is the east limb. So whatever data you have for that and these stops, plot it. And feed that into Stereonet, as we see here. Alright. So, cheers. So you're going to feed that into your Stereonet. Now you're going to want to do east limb first and then west limb. I don't know if that might be just a me thing. Could be you do it too. Who knows? But it doesn't really matter. So you're going to plot west. I'm plotting west limb now because I already did east limb. So just a quick rundown. I'm going to give you a little recap of what we're going to do. So you're going to want to make east limb and west limb different colors because that'll help distinguish them from each other, because at this stage when you're plotting bedding, it actually matters what you're looking at, whether it's the east limb or the west limb, because you're going to want to distinguish them and find the angle between them. And that will actually, once you do that, that'll give you your whatchamacallit, the fold angle. If they're parallel to each other, it's 0 degrees. If they're completely flat, it's 180 degrees. So it's like, it's a curved fold like that, and they end up being parallel to each other. Like the black part of my hand is the east limb, and the fingers here are the west limb. If they end up being parallel to each other and folded over that much, the angle between them is 0 degrees because they're perfectly parallel to each other. But if it ended up folding not at all, and these parts here, and here are completely flat, so they're 180 degrees. If it's somewhere like here, it's going to be like 35 degrees or 30 degrees, but you're going to calculate that. So now, plotting west limb data. And from this, we're going to find the mean pole. So we can average the data and eventually find the mean plane, so we know the rough average orientation of the entire east limb and the entire west limb, so we can find the angle between them. I need more vodka. This is probably really bad for me. Alright, being a YouTuber is tough. I have no idea what the hell to say, but we'll figure it out. Alright, so there you go. West limb data. I have 8 data points here, I think. Yeah, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. So I got 8 for east limb, 9 for west limb of the Tanner Hill synformal syncline in New York. Alright, so now look at that. That's just a complete mess. Bunch of red and blue data everywhere. So we're going to want to extract the mean poles from each of these so we can find the mean planes. So we're going to go to Calculations, Poles. Hit Poles, and it should plot for each. So click on East Limb, go to Calculations, Poles, and then go to West Limb and click Calculations, Poles. And we got a nice little smattering there of data. So we're going to click on the East Limb, which I put in red. You can put in whatever color tickles your fancy. And let's see, okay, East Limb. From there you go to Calculations, Fisher Vector Distribution. Click that, it'll give you a bunch of numbers down here, and those numbers actually become really important later, more than you usually use. So we see that the trend of the mean, all right, pulls the bedding, East Limb. Oh wow, it actually did both of them for me in one go. Nice. So apparently if you highlight one data set and click on Fisher mean vector distribution, it'll give you both the East Limb and the West Limb at the same time. So that's pretty useful. So now, because we have that data, we're going to go to New Data Set, Lines, and then input the plunge and trend of that mean vector distribution. So we see for East Limb down here, it's the trend is, the plunge first is 55 approximately. Trend is 266. Nice, right smack dab in the middle. All right, make that a different color because you're going to want to distinguish it from the rest of the data. So to do that, if you don't know already, which hopefully you should after being this long in Gene's class, go to View, Inspector, click on Inspector, go to the second tab over entitled Datasets, click on the color palette, and go down to white, and make it green. I'm going to make it green because that's a fun color. Okay, X out. All right. Now, at this point, in case your computer decides to crash, I'd highly recommend saving your work just in the event of a crash, or you happen to spill a ton of vodka all over your keyboard. Let's not make that happen. So I'm going to entitle this FT3 Stereonets, just in case. Cool. Make sure you don't have that title when you submit it to Gene, because she likes her file names all in order. Alright, so now you found the East Limb, click on West Limb, go down to here, trend and plunge, new data set, lines, again, find the trend and plunge for your West Limb. Trend plunge for me is 54. The trend is 265, which is fantastically close to each other. That is absolutely brilliant. Enter. Oh no, whoops, don't hit enter. Minus. Okay. So we're gonna change the color of this because I don't like it. I don't like it. Okay. View, Inspector, Dataset, Color. We'll make it purple-ish. That looks like a good color. Cool. No, purple's bad. Purple's bad because I have blue and red already. That's confusing. Let's do kind of like an orange. That's a nice color. That is a very, very good color. I like to see that. That's a good color. All right. Nah, looks too much like red. Let's make it, I used all the colors already. Let's use black. Good enough. All right. Now, you have your mean poles. So now that you have your mean poles and your total pole distribution, you can go ahead and uncheck the East Limb and West Limb planes. Gene specifically said you could do that because just so many colors in one plot is incredibly confusing, like honestly. So So you have your little mean vectors now. You can go ahead and title those whatever. Mean pole east limb and mean pole west limb. I really don't care what you decide to title them, but this just helps me. West limb. Perfect. All right. So now you're going to hit the data set for mean pole east limb, whichever west limb, I really don't care, it doesn't matter. Calculations, and then planes from poles. Bingo. And calculations, planes from poles. Bingo. Okay, so those two right there are your mean, those are going to be your mean planes for your east limb and west limb data sets. So now that you have those, it's going to be fairly... Okay, now from here, I have it really easy because mine are very close together and they're statistically similar enough where I can confidently say that they are 0 degrees apart from each other. Look, like here, get a closer view. The black and the light green right here, those are very close to each other. And we're going to go up to, just to make sure, we're going to uncheck these and these. And Shibuya, hallelujah, look at that. Those are so close together that I guarantee that when I plot the small circle for three-dimensional uncertainty, that these are going to fall within each other, and I can statistically, with 95% certainty, probably with 99% certainty, say that these are close enough together where I cannot distinguish the angle between them. So once I do that, I can legally, scientifically say that they are 0 degrees apart from each other, both limbs. So again, we have a limb going like this. Whoop. Perfect. Yay! Okay. All right. So now you're going to highlight your mean poles. And she showed this in class. Okay, yep. So you're going to want to refer back to your Fisher mean vector distribution. And I'm going to bring you close again so you can see it. A95 for east limb and A95 for west limb. That's the degree. Okay. I guess, you know what, let's just launch into full depth explanation. So in the Stereonet, as you know, from here, it's a lower equal area projection of a three-dimensional surface. So here you have a plane cutting from the center down into this area of the sphere. So like kind of cutting into the sphere. And that's what it would look like if you're looking from the top down on a hemisphere. From here, if you were to draw, it's kind of hard to think of and visualize in your head, but if you were to draw a cone with the circle, with the base of the cone down here, kind of making a little like ellipse, yeah, ellipse, down here with the vertex of the cone at the center of the Stereonet. That's kind of your three-dimensional error bar that scientifically you're going to want to plot if you're going to publish this in a paper or something, which Jean definitely wants you to publish this in a paper at some point because she's Jean. So, to get that little cone projection, you're going to want to go to New Dataset, Small Circles. And you're for trend and plunge, you're going to input the exact same trend and plunge you put for your mean, the mean pole over here. So black is west limb, so we're going to go to, all right, so we're going to make this east limb. east limb uncertainty, because that's essentially what you're plotting. And we're going to make this, go to view, inspector, yeah, whatever, make it roughly the same color as what you had before for whatever you had, whatever you're plotting. Shibuya, east limb, choose one. All right, now we'll go through the whole process first. So trend of my east limb for the mean pole is, plunge is 55, trend is 266, so you're gonna plot trend, oh, it's the other way, okay. Trend is 266, plunge is 55, angle, that's what you want. Angle is your alpha 95. So alpha 95 for the east limb is 4.7, and you know what, we're just gonna do it for shits and giggles. We'll plot it exactly as it says. Gene usually wants it plotted to the nearest whole number, so I guess we'll do that. But we're gonna do it to a decimal because we're fancy. So angle 4.7, bingo. So you see that circle right there, that big one? That's your uncertainty. And we already know that this is like, you can't be confident that they're different, so you have to assume they're the same data point because, I mean, look at this. Look at this shit. Like, that west limb mean pole data point, that's within the circle. Like, that mean pole is within the circle. That's definitely statistically insignificant. Like, you cannot claim that those two are separate. So, just for ha-has and all that, we'll do the same for the west limb in case your data set ends up being different from mine. So again, go to mean pole. No, don't even go to mean pole west limb. New data set, small circles from that drop-down menu. Thank you, Rick Allmendinger. Small circles. Okay. Small circles, go to your west limb data that you got from your Fisher mean vector. Trend, 265. Plunge, 54. Angle, alpha 95 value. Mine says 5.2, so we'll do that. Exactly. Boom. The circles are practically overlapping. If you have any overlap in your circle whatsoever, like if part of your circle kind of intersects the other and looks like a Venn diagram type thing, like there's some area of each circle that overlaps, then you cannot say that the limbs are angled apart in any way. You statistically are not allowed to say that. Mine are pretty much entirely overlapping, so I'm set. I cannot say that they are significantly different in any way whatsoever. So my limbs have a degree of 0. They are perfectly parallel, which is great. It means I don't have to do any extra work. So, west limb uncertainty. Shibuya. And that's that. Save, replace. Just in case. Alright. So that's how you plot bedding and determine whether the bedding is angled apart at all. If your uncertainty circles, your small circles did not overlap, then your bedding is angled apart in some way, or at least the measured bedding is angled apart, and you actually have to do additional calculations to determine what that angle is. Hopefully that's not the case. I really hope not. If it is, I can explain how to do it, but I don't want to do it now because this is the end. No, this is not the end. Okay, good. So now that you have your bedding data plotted, you're going to want to, let's see, what was the next step? Alright, blah, 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 ability proof, resource slam. Okay, so you're going to want to go to the basics leads for folds. Gene should have posted it somewhere, probably under reading. Yep, reading. The basics leads.pdf. Click on that. Open that file. And scroll down to page 23. Alright, on page 23, once you eventually do the calculations for the angle of the fold, you can qualitatively characterize it within a range of folds. So see here, whatever that angle is, you can classify it according to this diagram here. Mine is 0 degrees, mine is parallel, that's what I measured. Perfectly parallel. So that's 0 degrees, that is an isoclinal fold. And keep note of that because you will write it up in your Stereonet caption in content element 3, as you usually do, which we haven't done before. So no, you would not usually do that. But if you were to do this on a regular basis, you would put that in the content element 3 area of your Stereonet caption. Go back to Stereonet. Woo. Yay. Alright. So that's pretty much it for betting. Yeah, that actually is it for betting. So this is the end of Drunk Geology episode 1. Like, comment, subscribe. No, don't subscribe. Bad idea. Don't do that. Do not subscribe to this channel. I hate it so much. Don't look at anything, okay? See you in Drunk Geology episode 2. Bye.